Assalamu alaikum warahmatullahi wabarakatuh.
Alaikum salam warahmatullahi wabarakatuh.
Yeah. So inshallah, we need to start from the beginning. So the chemical bonding as well. So as I said in the previous classes that we've done, we said the chemical bonding it deals with the various attractive forces. So this is what I mean. This is what I'm reading. So chemical bonding. Yeah. So chemical bonding, it deals with the various attractive forces joining chemical species. So when they said bonding, it means either atoms want to join with other atoms or ion or molecules if they want to combine together. So, and we now said from the beginning of the chemistry, they said we have the two different types of bond. So before they extend it. So what are the two? We have the number one, we have the covalent bonding, and the second one is electrovalent bonding. So when we say electrovalent, it means we are actually talking about the ionic. Ionic bond, from the beginning, we said ionic bond is the transferring of electron. But in some textbook, they extend it in the fact that you can understand perfectly what they actually mean by what they actually mean by electrovalent bond. So this electrovalent bond, they said it involves the what? The transferring of electron. So how does this transferring of electron occur? It occurs between metals and non-metals. It occurs between what? Metals and non-metals. This is actually what I'm saying. Metals and what? And non-metals. So it occurs between metals and what? Non-metals. What are those metals? Metals of group 1 and group 2, and non-metals of group 6 and what? And group 7. So how does it now combine? So I said it earlier in the periodic table that when we have one valency electron, valency means the electron in the outermost shell. And I said when we have the valency electron that we mean, when it is one, it means that that element belongs to group 1 element. When it is group 2, it is going to have 2 electrons at the outermost shell. If it is group 3, we're going to have 3 electrons at the what? At the outermost shell, and so on and so forth. Now, for group 7, we have what? 7 electrons in the outermost shell. That shows that for this electrovalent bond to balance it, it will be between the metals of group 1 and non-metals of what? Of group 7. And or, let me just put it that way, or metals of group 2 and non-metals of what? Of group 6. Are we together? So in the last class, we talked about the shell, that we have the KLMN shell, right? So, and I said, how do we identify the KLMN shell? I said for the K shell, our N equals to 1, and we get it that we have 2 electrons. For K shell, we have 2. While L shell, we have 8. For M shell, someone said it is 18. Why the N shell is what? We have 36. I mean, 32. When N equals to 4, we have the formula that we use, which is 2N squared. And when N equals to 4, that's 4 squared. 4 squared is 16. 16 times 2, that's 32. That's what we actually have. So when N equals to 3, that's we have 3 squared. 3 squared is what? Is 9. 9 times 2, that's we have 18. This is what we have for the shell that we have. So for K shell, we have 2 electrons. For L shell, we have 8 electrons to make it complete. For M shell, we have 18. For N, we have 32. Are we together? Are we together, please? Class, are we together? Yes, fine. So now, we now said the M shell has been reduced to 8 due to the first 20 element. So due to the first 20 element, they've reduced it to what? To 8. So that we can get what we called what? Octet and duplet configuration. Because when you add this together, 2 plus 8 will give you 10. 10 plus 18, it will give you 28. It is more than 20. That's why they reduce it to 8 so that when we can actually define the valency. Are we together? So now this M shell has been reduced to what? To 8 instead of what? Instead of 18. Are we together? So that's what we have for that. Now, so we actually have this. And for the periodic table, for the group 0, which we know as, what do we call group 0? Group 0 element. What do we call group 0 element in the periodic table?
Group 8.
Group 8, we call it group 8. What's the name? What's the name? What's the name given to them? Instead of group 8, they have name. For example, group 1 element. They will say group 1 element. I don't want to give you this thing so that you get it. So what is the name? We call it what?
Noble gas.
Noble gas. We call it either noble gas, they are noble gases, or we call them what? Rare gases, or we call them what? What else do we call it? Okay, just go and find that. So we call them noble gases. So this group 0 element, so I said it in our last class that they don't combine with other elements, right? We don't find them in combined states. They don't combine with other elements. Why? Because they are completely filled. They are what? Completely filled. They either form this group 0, they either form duplex configuration or octet configuration. What is duplex configuration? Electron with 2. Octet, electron with what? With 8. Now, for example, give one example of rare gases. One example, one element for rare gases. Someone should give me argon. Argon is number what in the periodic table? Argon. What is argon in the periodic table? Number what?
18.
18. So now, if you want to draw the numbers of shell, for K shell, we have 2 electrons, right? For L shell, we have 8, right? This is what we have. But you can't teach 2 plus 8. That's what?
10.
10. So, and we are going to 18. It remains how many electrons to make it complete? It remains 8, right? So we have our 8 here. So because the valency is 8, that's why they call it octet configuration. Any element that you found that the valency electron is 8, we call them what? Octet configuration. Are we together?
Yes, sir.
Yes, the valency. So far the valency is 8. So, and this is, we said the K shell, it comprises of how many electrons? 2. The L shell, how many electrons are we going to have for L shell? We are going to have 8. For M shell, what are we going to have? Let's talk.
8.
For M shell, we are going to have 8. 8. So when you check this, it is 8. It is completely filled. It doesn't need, this argon does not need any electron to come in, maybe to transfer to it. Are we together? Or to remove from it? Are we together? So that's why we said they are octet configuration. You see it here that helium has a duplex configuration, while other noble gases have what? Octet configuration in their what? Outer energy level. So the outer energy level is what we call the valency electron. Are we together? So exactly, that was how it goes. So definitely now, so we said it's occur between metals and non-metals. Are we together? So I think I gave you two examples in our last class. Do you still remember? Or we should go with the example? We should go back to the example. Should we, or we should proceed? Let's talk, please. I can't hear you, oh, please. Let's talk. Am I the only one here?
So let's go over it again.
Okay, we should go over it again. So, for example, someone okay, someone So very sorry for that. I think it's my network. Sorry. So let's continue. So I said someone should give me one example. One example for group one element. Group one element,
Sodium.
please. Uh,
Sodium.
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 Someone said it's sodium. Sodium is number what in the periodic table? Number 11, right?
Yes, sir.
So let's go with the other one. The other one is chlorine. Make it sodium chloride. Chlorine is number 17 in the periodic table, right? So how do we go
Yes, sir.
about it? So if we are talking about the sodium, how do we write it? So sodium is number 11. We have the K shell, which is 2 electron, right? We have 2 electron. So the other one should be 8, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, right? So 2 plus 8, that's 10. It remains 1 electron to make it filled for sodium. We have 1 electron here. So another one is chlorine. Chlorine is number 17. For K shell, we have 2 electrons. Is that also? Yes, we have that. So the next one is we have 8. Sorry. We have we have 8 electrons. We have 1, we have 2, we have 3, we have 4, 5, we have 6, 7, 8, and we are going to 17. So the other one is the next shell, which is 7. 1, 2, 3, 4, 5, 6, 7. So that's what we have. We have the 17 for chlorine, but this one is 1. So now, and we are talking about the ionic bond, which involves the transferring of electron. You want to know which one will transfer 1 electron to the other. Now, this one, to make this one to be filled with this what? With this outermost shell, this one needs 7. To make this one to be filled with this outermost shell, this one need what? This one need 1 to make it filled. Now, but for this, so which one is now going to transfer its electron? Is the one with what? With the lowest electron, which is what? Which is that of the sodium. Sodium will now transfer 1 electron back to this to make it what? To make it 8. Are we together? So in this case, the answer will now be, this one will be, we will clean this, and the 1 electron from this, 1 electron from sodium here will be added to this, which will make it what? Which will make it complete. Are we together? So we now add plus to it. So, but in this case, to make it fast, you know, you are writing a term. So you don't need to draw the K shell, M shell. What you just need in bonding is the what? Is the valency electron in the outermost shell. We can quickly draw it that, okay, for the sodium, just write sodium. Well, the valency for sodium is what? 1. Why that of the chlorine? What's the valency? The valency for chlorine is what? Is 7, right? Just write this. We have this, and we have the 1 here. So this one is now transferring the 1 to the what? To the chlorine, to the valency of chlorine. So after that, we know that the other one that remains for sodium is what? Is 10 electron, while this one will now be what? Will now be 18 altogether. Are we together? Do you get it right? Valency. Valency is the electron in the outermost shell. Electron in the outermost shell. So the electron, the last electron. So electron in the atom, the shell. This is what we call the shell in chemistry, the shell. And I said we have the K, L, M, N shell. So we have O, but it is not for you. For the K shell, I said the electron that must be in K shell must be what? Must be 2. These are what we call shell. So the one that is last, the last shell is what we call valency shell, or the electron that is now there is what we call valency electron. So that it means the electron in the outermost shell. Is that clear? Do you understand? Okay, fine. So after that, thereafter, so we've known that this will transfer one electron back to this. Likewise, that of the group 6 and group. Someone should ask me a question that for the electrovalence, we said it is between group 1 and group 7, right? What of hydrogen chloride? Hydrogen chloride. Are they not the same thing? Hey, sorry, are we together? Hello? Okay. Now I said what of the, so there is this question that do confuse students, the hydrogen chloride. Hydrogen chloride, people do say it is electrovalent, while some also say it is covalent. Are we together? So, but how do we determine that? So, hydrogen is from group one element, right? Group one, it belongs to group one element, right? Are we together? So why chlorine? Chlorine is what group? Group 7, right? So now let's draw the electron for hydrogen. Hydrogen is K shell. For K shell of hydrogen, we have 1, right? Are we together? So, but for chlorine, for K shell, we have 2. We have 2 electrons. Sorry, we have 2 electrons for this. So the next one is L shell, and L shell is 8, right? L shell is 8. So we have 1, 2, this is 8. So now it remains M shell, and M shell we also have 8, but for the in the case of chlorine that is 17, we have 7, right? 1, 2, and we have 7. Now this is what we have for hydrogen and what? And chlorine. Now in this case, which one we now share between both of them? Which of the electron or which of the elements we share? Let's talk, please. I can't hear you. Talk. I can't hear you very well. I think you can hear me, but I can't hear you. All class. Hydrogen. Why? Why will hydrogen share? Let's talk. Why will hydrogen share? So anyone that can help us, please. Someone should bail us out. Okay. If hydrogen is sharing, would there be any electron for hydrogen again? Okay. What we're actually saying about, we said electrovalent, that electrovalent involves the transferring of electron. It is between metals and non-metals. Metals of what? Group 1 and group 2, and non-metals of what? Group 6 and group 7. That's what we're actually saying. We now said, okay, for that, we now said, okay, for the electrovalent, so it will be from between group 1 and group 7, group 2 and group what? Group 6. That's actually what we're actually saying about the electrovalent. So we've done an example between sodium. Sodium is now group 1, and chlorine, and we see that both of them can what? Can be electrovalent. It involves transferring of electron. That is, the sodium is transferring one electron in the in its outermost shell with chlorine. Are we together? Likewise, that of the group 2 and group 6, we've done it that group 2 we have 2 electrons in the outermost shell, while group 6 we have what? 6 electrons in the outermost shell. That 2 will be transferred to 6 to make it octet. Are we together? But for all those elements, we still have electron left with them. Are we together? So,
Yes, sir.
but in this case of hydrogen, hydrogen is group 1 and chlorine is group 7. Are they electrovalent? That's the question. Are they electrovalent?
Yes.
You said
Yes, sir.
yes, they are electrovalent. So this is now hydrogen. This is
They are
hydrogen.
covalent.
They are what?
Covalent.
How do we know it is covalent?
Because chlorine would have to share an electron with hydrogen for it to complete its duplex state.
Yes, this is K shell. And part of what we said is that for K shell, how many electrons are we going to have for K shell to make it complete? K shell. Class, let's talk. For K shell, how many electrons are we going to have?
Two.
We are having 2, right? So for this M shell, how many electrons are we going to have for M shell? Normally, how many electrons?
8.
8, right, fine. So, but here in this case, we have 7. That shows that chlorine needs 1 electron to complete its octet for M shell, right?
Yes, sir.
And for hydrogen, hydrogen also needs 1 electron to make it what? To make the shell to complete, right? Is that not so? So both of
Yes,
them
sir.
need 1, 1. So which one is now transferring? None of them will transfer. Because if hydrogen to transfer 1 to chlorine, that shows that hydrogen will not exist because it does not have any electron left anymore. Are we together? So if this one is also transferring 1 to hydrogen, so it means that this one is not yet completed what? Its octet configuration. That's why they said both of them cannot be electrovalent. Are we together? Unlike sodium, you know sodium has 1 electron in the outermost shell, so but still has electron left. It still has 10 electron if it is going to transfer 1 electron for chlorine. Still has what? 10 electron left. So that is why hydrogen and chlorine cannot be what? Cannot be. So that is why you will see it in some textbook. They don't classify hydrogen as metals. They don't classify it as what? As metal. Are we together? In some textbook, they don't classify it. They classify hydrogen as metalloid. Why? Because they said it behaves sometimes as what? Both metals and what? And what? And metals. So it behaves like non-metals in some aspects of chemistry, why it also behave as what? As metals as well. Are we together?
Yes, sir.
Do you understand?
Yes, sir.
Okay, so just note it down that hydrogen is not in metals. It's not part of metal. So it's what? It is metalloid. So sometimes it behaves as what? As non-metal, and it also behaves as what? As metal in sometimes. So in electropositivity, in that aspect, they see hydrogen as what? As metal, because it carries 1 ion. But in the case of diatomic H2, they don't see hydrogen as metal. They see it as what? As non-metal. Likewise in this bonding. So are we together? So that is why they don't classify it as what? As metal. It behaves like metals. It also behaves as what? As non-metal. So Are we together? So now, so that is for electrovalent ionic. So that's it. This is how they do it. This is the sodium. You will see that we have 2 electrons here. You see that one is here, one is here. We have 8. This is 1 electron at the outermost shell. So this is fluorine. Fluorine is number what in the periodic table? Number what? Fluorine,
Number 7.
number 7. So is it number 7 or number 9?
Number 9.
Number 9. So it means that for K shell, we are going to have 2 electrons. This is the 2. And from 9, when you remove 2, it remains 7. So this is the 7. Are we together? This is 1, 2, 3, 4, 5, 6, 7. It should be, okay, 6, 7. So now this one can be transferred. If this should be transferred, that shows that this shell is going totally. Is going totally because there is nothing again. Which left with what? 2 and what? And 8. Are we together?
Yes, sir.
Are we together?
Yes, sir.
Yes. In this case, we have 2 shell for sodium back. But for fluorine, so 1 electron will be transferred to make it octet for its L shell. So finally, we have 2 shell for them. Are we together? So that's how they draw it. So, and that's how it is. I think it is clear like that. So now, let's now go to the properties. Properties of what? Of electrovalent. So normally they ask these types of questions that, okay, for electrovalent and covalent, which one has high melting point and boiling point? Which has high melting point and boiling point? So the one that has high melting point and boiling point is that of the what? Is that of the electrovalent. Why? Because it is what? It is found between both metals and what? And non-metals. That shows that the metals we are actually talking about, it must carry what? Positive charge. While the non-metals we are actually talking about will carry what? Negative charge. And plus positive and negative, they are unlike charges. What do they do? Unlike charges, what does unlike charges do? Does it attracts each other. So when it attracts each other, they are going to have a melting point and boiling point. Are we together? So that's why water itself, it has the boiling point of 100 degrees Celsius. Why? Because when they split water into 2 equal parts, it forms what? It forms hydrogen ion and OH minus. Is that not so?
Yes, sir.
Fine. So electrovalents, due to their positive and negative electron, they what? They has what? High melting point and what? And boiling point. And they are what? They usually they are hard solid. So now number 2 is that they are soluble in water. They are soluble in water. Likewise, I said, for example, sodium fluoride. Sodium has positive. Why fluorine has what? Negative ion. Their electronegativity. When they dissolve in water, water also has positive and negative ion. So now they will quickly be dissolved in what? In water. Because they both have positive and negative what? Negative charges. They will what? It is easy for them to attract each other. Are we getting it, please?
Yes, sir.
So now they are insoluble in non-polar solvent. Non-polar solvent. When we say non-polar solvent, it means it does not have positive charges. Non-polar. So, but polar, it comprises of both positive and what? And negative charges. Are we together? So that's what we call polar and non-polar. So what are the non-polar solvents? Non-polar solvents are the one that we found in crude oil. So like petrol, like the kerosene, so and so on and so forth. Benzene is also non-polar solvent. What does benzene comprises? Benzene. What's the formula for benzene? Benzene is C what? C6H6. They are hydrocarbon. And hydrocarbon, anything hydrocarbon, they are what? They are non-polar. Hydrocarbon. Hydrocarbon are the what? Are the compound that comprise of both what? Hydrogen and what? And carbon. That's why we call them hydrocarbon. Hydrogen and carbon. Are we together? So benzene, we have 2-pentyne, and so on and so forth. This solubility behavior is in conformity with the general solubility rules, like dissolve like. Are we together? Just note this: like dissolve what? Like. If they are of the same like, they are going to dissolve each other. For example, sodium chloride. Sodium chloride. They has both positive and what? And negative. They are positive and negative. Water as well. H plus and OH minus. They are of the same like. So like dissolve like. That's what they actually mean. That is, the one that are what? Polar dissolve what? Polar. Because both of them comprise of both positive and what? And negative charge. Are we together? So that's all about it. So the next one is that in aqueous solution or in molten form, ionic compound, they are ionic compound, they are ionic bond. We call it, either you call it electrovalent or what? Ionic what? Ionic bond. Electrovalent bond, or you call it ionic bond. So we now said in aqueous solution, so or in molten form. So a ionic compound can conduct an electricity using free mobile ions as what? As carrier. So why do they say they can conduct electricity? Okay, in the battery that we are using, you found that it has both positive and what? And negative charge. Is that not so? So now, anything that has what? Positive that charge, it has the ability to what? To conduct electricity. Are we together?
Yes.
Hello? Are we together? Fine, we are together. So in that case, so they said they are what? Ionic bond or ionic compound. They are what? They serve as what? Electrolyte. They are electrolyte. Know that. They are electrolyte. You can't see the screen. I think it is due to your network. You can go back and come in. You can log out and re-log in. So they serve as what? Electrolyte. So you note that ionic compound can conduct what? Electricity. So that's it. So however, in solid state, the ions are arranged into crystal lattice and will not conduct a current of electricity. So don't forget that we said ionic compound in either aqueous or molten form. Either in aqueous or molten form. Aqueous form is the fact that they have what? Both positive and negative. So that's the aqueous form of ionic compound. So, but when they are in solid form, they don't have the capacity to conduct electricity. Are we together? Just note that as well. So now, reaction involves ionic compound in aqueous solution are very fast. When we have their reaction, when those ionic compound, when we have their reaction with aqueous solution, aqueous solution also has what? Also comprises of what? Both positive and negative. Their reaction also what? Are very fast. So because the like charges we repel, while unlike charges there we what? We attract. So that's all about electrovalent. So now the next one is that let's go to covalent bond. So electrovalent bond involved what? Involved the transferring of electron, while the covalent bond in this case involves the sharing of electron. What do we call it? Sharing of electron. The sharing of electron we are actually talking about is that both of them, they are going to share the same electron. For example, if I have two different elements and the bond that is between them is covalent, if one is sharing 2 electrons, the other one will also share 2 electrons. If one is sharing 4 electrons, the other one is going to share 4 electrons. So we have the logic that we use to do that, and it occurs between non-metals. You find the bond between what? Non-metals only. So are we together? So it is found between what? Non-metals. What are those non-metals? H2. We see that H2 in this case, as I told you before, I said H2. So it is non-metals. Are we together? So diatomic. The atomic of hydrogen. So because it behaves as what? Non-metals, right? So now H2 here is non-metals. O2, oxygen. 2 atoms of what? Oxygen. It is non-metals. 2 atoms of what? Nitrogen. We have 2 atoms of chlorine. We have HCl. We have H2O. We have NH3. We have CO2. We have CH4. All these, they characterize them as what? Covalent. If they give you one element or one compound and they said you should find the bond that exists between them, you have known either it is covalent or what? Electrovalent. And we are going to do example, hydrogen. For example, H2. So H2, that's the atomic of what? Of hydrogen. So what we need basically in this covalent, we need not to write everything all together. What we need is the valency. Now, it means we have 2 hydrogen separately. So what is the valency of hydrogen? Who can tell me? We have 1. Please, let's talk. I can't hear you guys, please. So for this one as well, it also has 1 electron, right? So now, before hydrogen can complete, how many electrons does hydrogen need to make it what? Complete?
1.
Can hydrogen form? Which kind of configuration can hydrogen form? Is it duplet configuration or octet configuration? Answer that question, please. Duplet configuration. That shows that to make hydrogen to be duplet, it needs how many electrons to make it duplet?
1.
This one, 1 electron. What of this one as well? Let's talk class.
1 electron too.
1 electron too. So far that both of them need 1 electron. In this case, they are going to share 1 electron to each other. So in this case, this hydrogen is sharing 1 electron to this middle. Why this as well is sharing 1 electron to this? So in this case, we can now say hydrogen, this hydrogen here has 2 electrons, it has complete. Why this one as well has 2 electrons, make it complete. Are we together? Both of them have formed duplet configuration. Are we together?
Yes, sir.
Is that okay? Now, so in this case, I will now teach you the types of bond that we have. I think I told you the different types of bond that we have in inorganic chemistry. I think we said that we have the pi bond and sigma bond, right?
Yes,
In
sir.
organic chemistry. Yes. So when we say pi bond, what does it mean? What does it actually mean? Pi bond. Okay, show me the differences between, one difference between, you log out and relog in Adebimpe, please. It is the network. I as well am battling with that network as well. So I'm just troubleshooting it. So now, tell me the difference between pi bond and sigma bonds, please. Let's be fast. It's something that we know. Let's talk, please. Class, let's talk. You don't have nothing to say. Okay, fine. When we say pi bond are the bond that cannot be, that can be what? That can be broken. Pi bond are the bond that can be what? Broken. Why sigma bond are the bond that cannot be broken? So pi bond can be 1 and can be 2. Why sigma bond can only be 1? We can actually have 1 bond for sigma bond, but pi bond can actually be 2, can be 1. Are we together? So in that case, and I told you that how many electron make a bond? How many electron make a bond? So 2 electron make a bond. 2 electron make a bond. 2 electron make a bond. So this is 2 electron. So in this case, it is 1 bond that we are going to have in this case. So hydrogen, between hydrogen and hydrogen. So we have only 1 bond attaching both of them, hydrogen and hydrogen. Are we together? I think we get it. So they form duplet. Just write it. Another example is oxygen, O2, diatomic of oxygen. Oxygen is number what in the periodic table?
8.
Number 8. What's the valency of oxygen? The valency of oxygen. 6, right?
Yes.
6, right? That's fine. That's fine. So oxygen is 6. So we have 2 oxygen. This is the first oxygen. This is the second oxygen. Don't mind my drawing. We have 6. We have 1, 2, 3, 4, 5, 6. Likewise, this one as well. We have 1, we have 2, we have 3, 4, 5, 6. How many electrons? What can this form? Is it the octet configuration or duplet configuration? Oxygen.
Yes.
It will form what configuration?
Octet.
Octet configuration. Now, for this oxygen, how many electrons does it need to make it octet?
2.
2 electrons. What of this one as well?
2.
2 electrons. So I'm now giving you this opportunity that the electron that both of them needs to make them to either be duplet or octet is the electron that both of them is going to share. This one need 2 electrons. Is going to share 2 electrons here. Why this one also need 2 electrons? Is going to share 2 electrons here. Are we together?
Yes, sir.
So in this case, 2 electrons will be shared from this to this middle. 1, 2. Why this one as well is going to share 2 electrons? It's going to share 2 electrons. Are we together?
Yes, sir.
So we have 2 electrons here. Is that okay? This one is sharing 2, that it remains to make it octet, and this one is also sharing 2. When you count this oxygen with this, you see that it will now be 1, 2, 3, 4, 5, 6, 7, 8. It has become octet configuration. Likewise, when you count these 1, 2, 3, 4, 5, 6, 7, 8, it has become what? Octet configuration. Are we together?
Yes, sir.
So it means that this is oxygen and oxygen together. So now, don't forget that we said 2 electrons make a bond, right?
Yes, sir.
How many bonds are we going to have between oxygen and oxygen here in this case? You know, we said 2 electrons make a bond. This middle, the one at the middle here. So we said 2 electrons make a bond. How many bonds are we going to have between oxygen and oxygen here?
2 bond.
two bonds. So we have oxygen. The two electron on top will serve as the first bond. Two electron downward will serve as the what? As the second bond. So the bond between oxygen and oxygen is what? Is double bond. That's why in chemistry, when you see oxygen and oxygen adding to reacting with each other, you're going to find what? Two bond combining both of them together. Is that okay?
Yes, sir.
Now, please, let's do N2 and give me the answer. N2 and give me the answer that we have for that. Please, quickly do that. And tell me how many bonds we are going to have between them. Just simple as that. So they are sharing the electron that both of them what? They are sharing equal electron for both of them. The one that the first one needs to make it complete will be shared together with the other one as well. So that's why we call them covalent bonding. So it involves the sharing of what? Sharing of electron. Quickly tell me, what's the answer, please?
Sir, is a single bond between them.
Single bond. Okay,
Yes,
let's
sir.
check if it is single bond.
Triple.
We have triple. Someone said triple. Someone said single bond. Let's now check if it is single or triple. So nitrogen. Nitrogen has how many valency? Nitrogen has how many valency?
5.
For nitrogen, nitrogen is number what in the periodic table?
7.
Number 7. For K shell, we have 2 electrons, right?
For L, we have 5.
For L, we have 5. I think my sister did not get the valency electron that we're actually saying. We have 5. So this is the 5 that we have. Barua, please mute your mic. Okay, that's fine. So this is what we call valency. Electron in the outermost shell. How many electron is at the outermost shell here? That's 5. That is why we said the valency electron for nitrogen is 5. 1, 2, 3, 4, 5. Are we together?
Yes, sir.
Likewise, the second nitrogen. We have 1, 2, 3, 4, 5. Are we together?
Yes, sir.
Okay, fine. So now, for this nitrogen, so how many electrons does it need to make it what? To make it octet configuration?
3.
3 to make it 8. 3. This one also need 3. And I said the electron that they need to make them octet are the electron that both of them is going to what? They are going to share, right?
Yes, sir.
So in this case, this one is sharing 3. So 1, 2, 3. Likewise, this one as well is sharing 3. 1, 2, 3. Is that okay? Now, if you now want to count the electron all together here like this, so it will be what? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Complete, right?
Yes, sir.
What of these as well? This one as well complete, right? So that's the covalent bonding. Are we together?
Yes, sir.
So now in this case, the bond that would be between them is nitrogen here with nitrogen, and we said 2 electrons make a bond. This is 1 bond, 2nd bond, 3rd bond. So we now have 3 bonds between nitrogen and nitrogen. Are we together? So this is what covalent bonding. So I think we should be able to do the other one. Let me do that of the hydrogen chloride, HCl. Well, are we done with the writing? Are we done with the writing, please? I
Yes,
think we
sir.
are done. Let's be very fast. So we'll soon end the class as the battery is already low. So let me just do the last one for HCl or CH4, whichever. You should be able to do that of the CH4. Okay, HCl, hydrogen. What's the valency of hydrogen? 1. Chlorine. Chlorine is 7, right? 1, 2, 3, 4, 5, 6, 7. This chlorine, it needs 1 electron to make it octet. Why this needs 1 electron to make it what? Duplet. 1, 1. This one needs 1 to make it duplet. Why this one needs 1 to make it what? Octet. Both of them is going to share it. Share 1 electron. Are we together? So this one will share 1 to this middle. Why this one will share the 1 here to this middle. When you count that of the chlorine all together, 1, 2, 3, 4, 5, 6, 7, 8 octet. When you count this, it has become what? Duplet 1, 2. Are we together? So that shows that the bond between hydrogen and chlorine is what? Single bond. Thank you. So let me just do the CH4 for you. CH4. CH4. Oh yeah, ask your question. What was Ajibade?
Sir, I was going through a question and I saw the question was like the bond between H2O, water, and hydrogen ion. That is, what's the bond between them?
The bond between H2O.
Yes, sir. And hydrogen ion to give H3O.
Okay, they said the bond between H2O
Yes, sir.
and hydrogen ion
Yes, sir.
to give H3O.
Yes, sir.
We've not reached hydrogen bonding. So you are
Okay.
going to know it through hydrogen bonding. So if
Okay.
it is the bond that is between H2O only, the bond between H2O, so we are going to identify that. So how do we identify that? That's oxygen. What's the valency of oxygen? What's the valency of oxygen? Oxygen is number 8, right?
Yes.
2. I'm sorry, sir.
Oxygen. Oxygen is number 8. It has how many valency?
6.
It has 6 valency.
Yes.
Are we not here? Hello?
6. I didn't know.
6. Hydrogen is H2. That's 2 hydrogen. 1 here, 1 here. This one has 1 electron. This one also has 1 electron. This one need one electron to make it complete, right? To make it duplet, right? Is that not so?
Yes, sir.
Why this one also need one electron to make it duplet, right?
Yes, sir.
Yes, sir.
Yes, sir.
Why this one now needs two electrons to make it what? To make it octet, right?
Yes, sir.
Yes.
Octet.
You know, the way they need hydrogen is quite different from each other. The way they need electron is quite different from each other. One hydrogen needs one electron to make it complete. Why hydrogen, the second hydrogen also needs one electron to make it complete, right? Why oxygen needs two electrons to make it complete, right? Is that okay? So, but in this case, oxygen, so is the parent cell. Is the parent what?
Sir.
Or we call it parent
Yeah.
element. Yes, we call it parent element. Parent element. Parent element means the element that can stand on their own. So in which other element can what? Can attach to. So that's why oxygen is parent element, because it is what? It is only one atom. But hydrogen, it is two atoms. They are not what? They cannot stand on their own. That's why they are what? They are not parent element. But in this case, oxygen is the parent element here. Now, this, to make it complete, so that shows that this hydrogen needs one electron. Why this hydrogen as well needs one electron? Are we together? So in this case, this hydrogen itself is going to share one with oxygen. Why this oxygen is going to share one with this. Are we together?
Yes, sir.
Hello? Now,
Yes, sir.
this one as well, this hydrogen is going to share one here. Why this oxygen is going to share another one with this, with hydrogen. You will see now in this case, the oxygen, which is the parent cell or parent element, is sharing one electron together with what? With two hydrogen, because this oxygen needs two electrons to make it complete. That's why it's sharing two. Are we together? So this one needs oxygen needs two electrons to make it complete. That's why it's sharing two. Why hydrogen needs one electron to make it complete? That's why it's sharing one. Are we together?
Yes, sir.
Yes, sir.
So in this case, if you don't want to count the total numbers of electrons that oxygen has, you count everything together with oxygen. Let's check if it is what? If it is complete. You now count it as what? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. This hydrogen, this is the hydrogen. So it has become what? Duplet. Fine, perfect. Why this as well has become what? Duplet as well. Is that okay? That now shows that oxygen with this hydrogen, one bond, right?
Yes, sir.
And oxygen with this hydrogen is another what? Is another bond. Are we together?
Sir.
So
Yes, sir.
now, in the previous example that we did for oxygen O2, how many bond is attached to them? How many bond? Oxygen to oxygen. How many bond do we have attaching to oxygen?
Two bond.
Two bond. So now you now see that in this case as well, we also have two bond attaching to what? To oxygen.
Yes,
Are we
sir.
getting it? Are we getting it? So valency electron help us to determine how many bonds will attach to each element. I think you are okay with that.
Yes, sir.
So now, my sister Ajibade, so
Yes, sir.
if they ask you that the bond that exists between water, so the bond that exists between water is in form of what? Covalent bonding. But the bond between H2O and hydrogen ion, to make them to become oxonium ion, it has become what? The so-called hydrogen bonding. So we are going there, don't worry. Is that okay?
Okay, sir. Yes, sir.
Are we okay with that? So you should be able to do CH4 with this example, and you should be able to do HCl as okay. We've done HCl, so and all the rest. Is that okay?
Yes, sir.
So I think
Yes,
we
sir.
are fine. Any question? Any question? Do you have any question?
Sir.
Do you have any
Sir.
question?
Sir, can you talk more on that sigma bond and
I can't hear you, Ali Dayato.
that stigma bond and pi bond?
Yes,
Yeah,
it's
I
not
said, can
clear
you?
to you, right?
Yes, sir.
I should explain.
Yes, sir.
I can't hear you, please.
Yes, yes.
Okay. Now, when we are talking about the sigma bond, for example, for instance, when we have carbon to carbon single bond, so we only have sigma bond because it cannot be broken. Do we understand now? But when you have carbon to carbon double bond, and don't forget that we said we only have one sigma bond, but pi bond can either be one or two. In this case, this is sigma bond. Why this is pi bond? We only have one sigma bond. So when you have double bond, it means that you have one sigma bond and one pi bond. When you have triple bond, it means that you have one sigma bond and two what? Two pi bond. That's actually what we are talking about, right?
Yes, sir.
Are we okay with that?
Yes, sir.
Yes, sir.
Okay. So far in our next class, so we are going to discuss further. Is that okay? So thank you very much. So don't worry about the classes that we said we are going to do. So I'm going to talk with the lead tutor, and he's going to find time for us to do the lead free. All right. So bye. Thank you very much for coming.
Welcome, sir.
All right.